Hi, everyone. My name is Steve Baird. I'm the research coordinator here at Kachemak Bay Research Reserve, and I just wanted to share with you some of the long-term monitoring we do here at the reserve. And we refer to this program as SWAMP, which stands for System-Wide Monitoring Program. It's called system-wide because it's done consistently, following the same protocols at all the research reserves around the United States, from Puerto Rico to the Northeast to Hawaii. The data are really robust, they undergo a lot of quality control, so it's a good long-term data set. So the program mainly consists of water quality and atmospheric monitoring. And we have water quality instruments installed at locations like the photo shown in the top. That's near the end of the Homer Spit at the ferry dock. And those instruments record things like water temperature, pH, salinity, dissolved oxygen, turbidity, and at some of them they record chlorophyll A. All of those can be significant for both marine invasives and potentially harmful marine species like harmful algae. Then we also have two weather stations. The photo on the bottom right shows our weather station at Anchor Point. Those have been running since 2003, and they record the things you think of recording at a weather station, like air temperature, humidity, barometric pressure, wind speed and direction. Then they also record something called PAR, which is basically just the portion of sunlight that stimulates photosynthesis. And so that could be very important for especially plankton in Kachemak Bay, as you can imagine. Just to show you where these stations are located, here's Kachemak Bay, and we have two weather stations, one in Anchor Point, one at the end of the Homer Spit. That end of Homer Spit location is really nice because it gives us the air temperatures and wind out over the bay, basically, because the spit sticks out halfway into the bay. So unlike the weather station at the Homer Airport, which is giving you land-based weather, the Homer Spit is really more marine weather. There's often quite a temperature difference between there and the airport and Homer, and wind speeds can also be very different. And then we have three locations where we have water quality instruments. In Seldovia at the ferry dock, in Homer at the ferry dock, and in Bear Cove on a buoy. And that Bear Cove buoy needs to be taken out seasonally, so we only have basically ice-free season data for Bear Cove. At both Homer and Seldovia, we have instruments paired, one above the other, one down near the bottom in about 8 to 10 meters of water, and one just a meter under the surface. So we're able to see if there are differences between the deep water layer and the surface water layer. Now that we have almost 20 years of data, as I mentioned, we can start to look at long-term average patterns. So this graph just shows you the long-term temperature patterns with the months or the days running along the bottom axis, the x-axis, from January 1st to December 31st, and water temperatures at the various water quality sites in those different colors. And a few things that you can notice looking at this graph is that the Homer stations are generally colder. Well, not generally, on average, they're colder in the winter than the Seldovia sites. The reason for this is that Seldovia sites are more directly connected with the Gulf of Alaska, the Lower Cook Inlet, than the Homer sites. So you get that marine influence, and oceanic waters are warmer than more nearshore waters in the winter. In the summer, temperatures diverge quite a bit more, and while the Homer Deep site is the coldest on average, even during the summer, the Homer Surface site is warmer than both of the Seldovia sites by quite a bit. And then that Bear Cove seasonal station is, again, quite a bit warmer than any of the others in the summer. And I would guess that holds true for most of the sub-bays on the south side of Kachemak Bay, like Peterson, Halibut, Sadie Cove. In the fall, you can see in about October to early November, the temperatures converge in the whole bay. And that's, so at that time of year, basically the entire bay has similar water temperatures. Here's the same thing for salinity. Again, the average annual patterns over this 20-year period. Well, less for Bear Cove, but 20 years for the main sites. And while you can see that the Homer Deep, the dark green station, and the two Seldovia stations in blue basically have marine water year-round. So at or above, near or above 30 PSU, which is practical salinity units. Whereas Homer and Bear Cove, Homer surface, sorry, and Bear Cove become quite a bit fresher in the summer. So you've basically got a freshwater lens that develops. And this shows up at the Homer side because basically what's happening is salt water enters Kachemak Bay around Gore Point, coming in on the south side of the bay, runs east and north along the south side of the bay before crossing over to the north side, and then flows out of the bay on the north. So you've got basically a counterclockwise circulation pattern of overall of water in the bay. And as that marine water comes in, it gets more and more input from all the various streams and just rain runoff. So by the time it hits the Homer Spit, it's got, at the surface anyway, it's got a lot more fresh water mixed in with the salt water to lower the salinity and bring us also warmer temperatures. So I've shown you average annual patterns, and what we can do if we're curious about any individual year is compare the patterns in that particular year to the average annual pattern. So in the blue here, again, it's days of the year across the bottom, x-axis. And the blue is the average annual pattern for our Seldovia Deep Station. And the light blue bars, if you can see those around the blue line, are there's one standard deviation around the line. So it shows sort of an idea of the variability of water temperatures on any given day. And then the orange line is the 2019 temperatures, average daily temperatures. And you can see that for almost the entire year up to this point in November or late October, Kachemak Bay waters were significantly warmer than the long-term average. In spring, they were, more than a standard deviation warmer than the average. And again, in late June and early July, I do have this is a graph I created in November, but I do have the later data, and it stayed significantly warm in Kachemak Bay for all of 2019. Here's the same thing with air temperature. Now, air temperature is noisier because that mass of water in Kachemak Bay, the giant mass of water, takes a long time to heat up and cool down, whereas air temperatures can heat and cool more rapidly. So you see more jaggediness, but again, you can see that for most of the year, the 2019 air temperatures shown here in red were significantly warmer than the long-term average temperatures in gray. So that's a way to compare a single year to the long-term average. But if we want to look at longer trends, look at multiple years at the same time, we often use something called anomaly plots. And these might seem confusing at first, but they're actually very simple. Each bar up or down represents a single month's average, and how different that month is from the average for that same month across all the data sets. So anomalies basically show how different a given month is from the average. So if your month you're looking at is right at the 0 line, it means it was exactly the same as the average across all of those months. An example here is January 2004. The waters at the Homer Deep Station were about 1.5 degrees centigrade cooler than the average for all Januaries. So it's only comparing January to January, March to March, etc. The thing that really stands out here is that for about 6 years now, we've been in a very serious positive anomaly. In other words, water temperatures are significantly warmer than the long-term average for all months. The early part of that, 2014, 15, and 16, is when we had that North Pacific warm water anomaly, or the blob, it was often referred to in the press. So there was this blob of warm water sitting out in the Gulf of Alaska, and that was reflected in water temperatures in Kachemak Bay. Then in 2017 and 18, it looked like our water temperatures were getting closer to normal, but you can see in 2019 looks like a blob year again. 2019 was anomalously warm for the entire year. And warm water affects things like invasives and harmful species. You know, if you're a green crab that's used to living in warmer waters farther south along the West Coast, as waters warm up here, the habitat may become more suitable. Similarly, if you're it's been shown that some harmful algal blooms like Alexandrium are more likely to occur when water temperatures are warmer. So warming waters, you know, it's a change can lead to either good or bad things and may encourage some things we don't like. If you like to go swim, be nice. Here's this similar thing with salinity. These are anomalies again, so how different each month is. Salinity is a little noisier, but you can see for that same last 5 to 6 years, there's been a lot more freshwater anomalies than saltwater. So negative anomalies here means the water is fresher. And so we've had both warmer and fresher waters in Kachemak Bay for the last 6 years on average. A final thing I wanted to show you is pH. pH is very noisy, but at all 4 stations now, 4 long-term water quality stations, we are seeing a decreasing trend. That red line shows the trend over time, just a linear trend. And you can see that it's decreasing. Decreasing pH is consistent with the phenomenon of ocean acidification. So it's not enough alone to show that ocean is acidifying. You really need to look at the water chemistry in detail, but it's one indication that our waters may be becoming more acidified in Kachemak Bay than they have been historically, which is consistent with the idea of global climate change. So just to wrap up, surface water in Homer and the subbase on average in any given year is warmer and fresher than the rest of the bay. So Homer's surface and the subbays look like they are usually warmer and fresher. In 2019, our water and air temps were significantly warmer than the long-term average. We're into 6-year stretch now of mostly warmer and fresher water in Kachemak Bay, with 2019 looking very similar to the warm blob years. And we see possibly a trend of decreasing pH, which would be consistent with ocean acidification. And that's all I had today. We're always collecting these data, and there are many other parameters we measure, as I mentioned. So hopefully, as things change in the bay, we'll be able to understand those changes based on our long-term monitoring. Thanks.